So now let's have a look at the chapter on generators. Always a nice topic to talk about. There's a lot of things we can explain about it, but we're going to try to keep it as focused and brief as possible. So first, to get a couple of things out of the way, what we are talking about is a generator set. So a generator set is the combination of an internal combustion engine with an electrical generator. And what we are using for the electrical generator is an alternator. So this is what we are referring to as a generator. Now, I'd like to discuss 4 different topics. I want to first look at the lingo, so the technical jargon that you often come across when we're talking about generators, when we're looking into this topic, so that we can make sure that we speak the same language. Then I want to look separately at the standard, so the conventional type of generators, and in a different section we'll look at the inverter generator types. And then the last section I want to look at the different kind of fuel options you have and what the pros and the cons are. So first, let's get some theory out of the way and look at the technical jargon, so the kind of terminology that we often come across when we're talking about and looking into the topic of generators. So the most obvious one is regarding the operating voltage of the generator. So the voltage is the electrical pressure, if you will. It's indicated in voltage or in volts. Sometimes it's indicated in kilovolts and kV. So 1 kilovolt equals 1000 volts. But then there's quite a few other terms. So we've got the single phase, dual phase, 3-phase, we've got amperage, kilowatts, kVA, watts, and frequency. So let me cut this up into 3 different sections. So we'll look at the volts and amps separately, at the power ratings, and at the frequency. I'm going to try to keep it as simple as possible. I just want to clarify them all individually. So let's start by looking at the voltage and the amperage. So the first thing to realize is that the output voltage of your generator fluctuates over time. It depends which kind of type, model, and quality of generator you have, but it can fluctuate as much as 5 to 10% up or down. Now, your generator is able to modify the output voltage, and it does this by controlling the internal magnetic field inside of the generator, so inside of the alternator. But it's important to realize that the real reason behind why your voltage is fluctuating and why the generator needs to adjust the magnetic field strength is basically because of you. Because if you are changing the loads on a generator, if you are reducing the amount of power that you're taking from it, or all of a sudden you're taking more power, you're asking more power from the generator, then the result is that the voltage starts to fluctuate, and therefore the generator tries to mitigate this by adjusting the field strength of the magnetic field inside. Now, you might have seen this kind of a graph before, whereby on the horizontal axis we've got the time, and on the vertical axis we've got the output voltage of your generator. In this kind of a graph, you can clearly see how the current of AC alternates, right? So it's high, then it's neutral, then it's negative, then it's neutral, then it's positive. So it's just important to point out that the height of these waves, they determine the output voltage of your generator. And if you would compare this to a DC power source, or a direct current, then the voltage of a DC source is just stable. It shouldn't fluctuate over time. Now, these are all just words and numbers and graphs, but I think I can do a much better job at explaining to you the differences between voltage, amperage, and power by drawing a very simple but effective analogy between these electrical terms and something way more tangible out of real life. So I introduce to you my dear friend John, who has at his disposal a tank filled with water, slightly elevated above ground level. He's connected a hose to this water tank, and he's now watering the garden with this system. Now, John is getting a little bit of pressure out of his hose because he elevated the water tank above ground level. Now, you can compare the pressure in the hose to the equivalent of electrical pressure. And this is what we refer to as voltage. So just compare the pressure in the hose with electrical pressure called voltage. Now, if we would keep the situation as is, but we would change only one thing, we would increase the diameter of the hose quite substantially. I'm sure you can understand that there's now more water flowing out of the system, right? So you can imagine that the amount of water flowing out of the hose is in some way similar to the amount of current, so the amount of amperage in an electrical circuit. Now let's change the system back to its original condition again. So we reduce the diameter of the hose, but now instead what we would change is we would raise the tank quite a bit further off the ground. So it would give the system much longer legs. Now you can imagine that as a result, you've got much more pressure available at the end of the hose, so much more water is coming out. But now imagine that if you would also increase the diameter of the hose, even more water is coming out. So a very large quantity of water is flowing out of the hose at this point. So I'm just explaining it in this simple way because I think this makes it very easy to understand that the amount of useful power that you're getting out of the system is the equivalent of the pressure times the flow. And so the electrical equivalent is that the power that you're getting out of your electrical system is the voltage multiplied by the amperage. So well done for sticking with me so far. If you keep this thing imprinted in your brain, so power equals voltage times amperage, you're way out of the rest because it's a very basic principle, but you'll see it coming back a lot of times, and I'll often, throughout the whatever I'm explaining, I'll often refer to this principle. So now, all right, let him shut up for a second. I just want to explain to you that the content of this video is copied from the complete course of off-grid energy systems. If this information is enough for you, great. If you want to learn more and if you want to get access to the complete course, then check the information in the description below. Alright, you go ahead again. Now that we got voltage and amperage out of the way, let's look at the next subtopic in this chapter, which is regarding power rating. So how is power being identified and what kind of terminology are we using to describe power? So the story of power rating starts at its very foundation because 1 unit of energy is described with the unit of joule. Now it's very unlikely that you'll come across this terminology. What is more likely that you'll see is something described as the amount of energy flowing. So if every second 1 joule of energy would be consumed or produced, this is then described as 1 watt. So I'm explaining this because it's important to realize that the unit of watt actually refers to an energy flow. It's not a quantity of energy, but it is a quantity of energy over time, an amount of energy flowing through your system. Now the next point is quite simple because you might often come across a value of kilowatt, not watts. So 1000 watts equals 1 kilowatt. Now it gets a bit more tricky, a bit more confusing when manufacturers or specification sheets are describing the term of volt amps VAs instead of watts. Now, under perfect ideal situations, 1 watt is equal to 1 VA, to 1 volt amps. But in more realistic, more average scenarios, you can assume that 1 watt equals around 0.75 VA. Now, the exact ratio between the watts and the volt amps is determined by a factor which is referred to as the power factor. And the power factor is a value between 0 and 1. Now, for now, I'm not going to dive too deep in this topic for now, but it's just important to realize that the power factor is determined by whichever kind of appliance you're connecting to your power source. So whatever you're connecting to the power source determines the power factor. It is not the power source itself. So it is not your generator that determines what kind of a power factor is applicable to your situation. I'll explain you more about the power factor later on. For now, just remember these 2 things. 1000 watts equals 1 kilowatt, and under ideal situations 1 watt equals 1 volt amp. So we're making good progress. We're almost done with the boring technical stuff. You understand now the difference between volts, amps, and how to indicate the power rating. Let's look at the last topic regarding frequency. So you know by now that your generator produces alternating current. So the voltage fluctuates in a very stable way over time. The height of the graph indicates the actual voltage of your system. So now what controls how fast that graph fluctuates, right? Why is it not going very slow? Why isn't it going very fast? So this is being controlled quite simply by the speed of your engine. So the faster your engine runs, the higher the frequency is. The slower your engine runs, the slower the frequency is. Now, whenever you buy a generator, you don't have to control this. The manufacturer has already fine-tuned this. And depending on where you live, what kind of a system you're using, it is set that the frequency is either a 50 or 60 hertz. So 50 or 60 times per second, this wave is going up and down as a result of the speed of your engine. Okay, well done. You finished the theoretical part. It was just important that you understand the fundamentals so you and I speak the same language. So now let's start by looking actually into the different types of generators. So let's start by looking at the standard conventional type of generator first. Now there's 4 topics that I'd like to discuss. First, we'll look at the fuel consumption and what influences the fuel consumption. We'll look at the different kind of outlets, the different kind of connections that you might want or that you might want to consider for your generator. We'll look at the capacity, so what kind of a generator size should you or would you want to choose. And at last, we'll look at the different kind of features. I want to point out a few features that you might want to consider for your generator. So let's start by looking at the fuel consumption of your generator first. Now, let me just clarify one thing. Since I do not know what type or size of generator you have or will buy, I'm not able to tell you the absolute amount of fuel per amount of time that you're running your generator, but what I will be able to indicate is the average values that you can expect for the amount of fuel that you consume per amount of energy produced, if that makes sense. So what I can tell you is the amount of fuel in gallons per the amount of energy produced in kilowatts, or the amount of liters of fuel per the amount of energy produced in kilowatts. So here are some average values for you. If you are running your generator under 100% load, so under its maximum standard rated capacity, then you'll be consuming approximately 0.17 gallons per kilowatt or 0.64 liters per kilowatt. But now here's a tricky bit. If you have substantially oversized your generator, and instead of running your generator at nearly full or full capacity, you're running it at, say, 50% capacity. Well, now your fuel consumption would be 0.23 gallons per kilowatt or 0.87 liters per kilowatt. Now, I'm explaining this to you because here's a thing that a lot of people don't realize. If you are running your generator at a fairly low load, so at 50% of its load, it's definitely true that you'll be consuming less fuel per minute, per hour, or per day. That's absolutely true. But at the same time, you're also getting a very poor fuel efficiency out of your generator. So yes, it's true, at 50% of its load, you're consuming less fuel, but the amount of energy that you're getting out of 1 unit of fuel is also substantially less. So in this example, you're getting 35% less fuel efficiency if you're running your generator at 50 versus 100% load. So let me further explain this to you with a simple calculation. So I assume that you have some kind of appliance that consumes 4 kilowatt. It can be a stovetop, an air conditioning, a heater, whatever. You have an appliance that consumes 4 kilowatt. And we are going to power up your device with a generator, and we have 2 different scenarios. In the first scenario, we oversize your generator, and in the second scenario, we match the capacity of your generator to your load. So in the first setup, we oversize your generator, so we pick an 8 kilowatt generator to power up your 4 kilowatt load. So as a result, this generator is now operating at its 50% capacity, and let's say you're running this load straight out for 10 hours continuous. Then the fuel consumption of this generator during the 10 hours will be 9.2 gallons. So that's pretty straightforward, right? Now let's assume that you take a generator which is a perfect match with your load. So your load is 4 kilowatt, and you choose a generator which is also 4 kilowatt. So now this generator will run at 100% of its capacity, therefore it will be consuming approximately 0.17 gallons or 0.64 liters per kilowatt, and therefore if you run this load 10 hours straight, the end result is that with this generator setup, you'll be consuming 6.8 gallons over the 10-hour time frame. So now it becomes clear that in the first scenario, you're spending substantially more fuel on powering up the same load. You're spending more than 2 gallons or more than 8 liters more compared to the second scenario, which means that in the second scenario, you're spending less on your fuel consumption and you're spending less on the initial purchase of your generator, which is pretty good, right? So that's enough about fuel consumption. Now let's look at the second topic regarding the outlets of conventional standard generators. Now, this topic is not rocket science. Just make sure that you match your kind of loads that you intend to power up with your generator with the right type. So choose for single phase, split phase, 3-phase. Just match your loads with the right type of generator. But there's one thing which is often overlooked, which is regarding the DC, the diode current capacity of your generator. So most standard or advanced generators have the ability of you connecting a battery straight to your generator. But I just want to say that often people get a bit disappointed because they think they can charge a large battery bank, but just double check, because most standard generator can charge with around 8 amps. So at a 12 volt operating voltage, that's, just 100 watts of charging capacity, which is, enough to charge very small appliances or to charge a conventional starter battery. But if you have a big house battery bank, a deep cycle battery bank, you won't be able to charge it properly with this kind of setup. Which brings us to the next point regarding the capacity of the generator. There's just a few simple items here that I want to explain. So the first and obvious one is the nominal or rated power of the generator. So this value refers to the amount of power that you can withdraw from the generator under normal operating conditions without any problems occurring. So you can continually draw this amount of power from the generator without it overheating or breaking down. But there's a substantial difference with the second one, which is the peak power or the max power output of the generator. So just make sure that you understand the difference between the two, because the maximum amount of peak power of a generator, that rating, you can only do it for a short amount of time. And this is also indicated by the manufacturer. So yes, you can draw this amount of power from the generator, but only for a short amount of time. Sometimes it's 10 seconds, sometimes a minute, sometimes 10 minutes, but you cannot continue to withdraw this amount of power from the generator without something to overheat or something to trip. So the units used to describe the nominal, rated or max power of a generator are normally the watts or the volt amps, or a multitude of that, as we saw before, the kilowatts or the kVAs. So here we bump again into that issue of the power factor, right? Because the difference between the kilowatts and the kVAs is determined by the power factor of your loads. So as promised before, let me explain to you a little bit more about the power factor, what it is, and how you use the right power factor for determining which kind of generator is correct for your setup. So let me explain this with a simple example. So imagine that you would want to power up your fridge with a generator. And you already know what the power consumption of your fridge is. You've looked in the specification sheet or on the sticker on the back of the fridge, but it only gives you this value in watts or in kilowatts. And now you're looking at a specific generator online or in the store, and this generator only gives you the rated capacity, the max and the nominal capacity, in kVA. So if you want to convert the rating in kVA towards the rating in kilowatt, you multiply the kVA rating times the power factor. And remember, the power factor is a value between 0 and 1. So as mentioned before, the exact power factor depends on your situation, depends which kind of load, which kind of appliance you intend to connect to your generator. But values which you can expect for the power factor are, for example, for LED lights, they have a power factor of close to 1, so that's pretty good. But any kind of appliance which has an electric motor inside has a potentially low power factor. So a fridge, for example, works with a compressor, and inside of the compressor there's an electric motor. So fridges can go as low as 0.5, 0.6. But if you have the more advanced, more newer kind of fridges, then they often have electronics installed that kind of compensate for the bad power factor. So they might go as high as 0.8 or 0.9. So by now you understand what power factors are, how they relate to the calculation of the final capacity of your generator, and we have looked at the different kind of outlets and the fuel consumption of your generator. So now let's look at the last point, and I just want to point out a few specific features which you might want to consider for your choice of generator. So the first one is a very simple, but in my opinion, an essential feature to have, which is the fuel valve. And believe it or not, there are generators out there that don't have a fuel valve. So the fuel valve just allows you to troubleshoot your system much easier. It allows you for draining your fuel system. So if you're not using it for a while, you can turn off the fuel valve, you can run your generator empty, and this prevents a lot of problems later on. So at least make sure that you have a fuel valve. Doesn't matter which model exactly. Sometimes it's a very simple, metal or plastic valve. Sometimes it looks a bit more fancy with a big disc that you can turn, but in essence, it's just a basic fuel valve. And the second one is for you to consider an electric start. And whenever you're looking at the difference in prices, yes, you'll pay whatever 10-20% more for your generator, but I also strongly recommend that you get this one because it's such a great convenience to have this electric start option. It does add a little bit of complexity to your system because now you have a battery that you might have to replace after a couple of years, etc. But it creates so much value at the same time too. For example, if you're troubleshooting your system, it's pretty easy to just crank the engine for a couple of seconds straight, and this might make it much easier to, I don't know, if you have a fuel lock or if you want to test your spark, etc. So it's a great feature to have. So allow yourself some comfort and consider going for the electric start option. So I think this is enough you need to know about the conventional normal generator. Now let's look at the third section within the generator chapter, which is about the inverter generators. So as the name already suggests, the basic functionality of an inverter generator is made out of two components: a conventional normal generator combined with an inverter that just fuse together into one housing, and this is what we refer to as an inverter generator. So we're going to look at this information in 3 different sections. We'll look at what actually happens inside of the generator, and we'll look separately at the pros and the cons of inverter generators. So what happens inside of the inverter generator is that the electrical generator part of the generator produces alternating current. Then this alternating current is being crushed back into a simple DC power source, or a simple direct current. And then this direct current is then turned through the inverter back into alternating current again. So this seems a bit weird, right? You've got AC, you turn it back into DC, and then back into AC again. Why? Well, this is because the AC created in the first step can be somewhat irregular. So if you take this irregular AC power from the first step and then crush it back into direct current, which is pretty easy to manage, and then you build it back up to an AC source, then your final AC wave is very stable and very controlled. And this is the reason why manufacturers and suppliers of inverter generators will claim that the output of their inverter generator is much more stable, is much cleaner, and is much more controlled compared to the output of a conventional regular generator, which in most cases is absolutely true. So now that you know what happens inside of an inverter generator, let's look at the pros. What are the benefits of an inverter generator? So the first clear advantage is that inverter generators on average produce really high quality stable power output. And the second clear advantage of inverter generators is that since the third step, so the generation of AC power by the inverter, is decoupled from the first step, whereby the electrical generator creates the first AC power, you are now able to actually run the engine at a much lower engine speed, but at the same time still providing the correct frequency and power output that's being created by the inverter. And this is a great benefit because you're not able to do that with a conventional generator. A normal conventional generator needs to run at the same engine speed all of the time in order to maintain that frequency that we discussed before, right? So if in your situation you sometimes might require less power from the generator, and as a result the generator will just reduce its engine speed while maintaining the proper frequency, now a result of this is that you have substantially less noise output from the generator. Now this is a great benefit of inverter generators, but just realize that if you're running your inverter generator at its maximum capacity, the engine speed is also maximum. So you might very well be producing the same amount of noise level with an inverter generator that's running at 100% capacity compared to a conventional normal generator. The real advantage of an inverter generator kicks in when you're starting to run it at lower capacity, whereby the engine speed reduces, your fuel efficiency remains somewhat the same, but your noise levels just drop drastically. Now these are the advantages of inverter generators, but of course if you want you can also point out the disadvantages. So the first one is quite obvious. Inverter generators are substantially more expensive compared to the traditional conventional generators. And you could also argue that since there are more components inside of the inverter generator, right? Because now it's not only a generator, but there's also an inverter built into one unit. You could say that with more components, you increase the chance of components to break down. So you could argue that the reliability might be a bit lower, or that it's more difficult to repair it once it does break down. And this then links to the KISS method, right? Keeping it stupid simple. So, but this is more of an opinion base. So I'll let you figure out what you think about this point. Now, I think this is enough we need to discuss regarding inverter generators. Let's look at the last topic in the generator chapter, and we'll look at the different kind of fuel options that you might want to consider for your setup. For the fuel options, we'll look at 3 different kinds of fuel, so gasoline, diesel, and bottled gas, or LPG. And I'll give you the values for the North American market, so I'll use the unit of dollars per gallon. Now you can clearly see here that gasoline is just a little bit cheaper than diesel and a lot cheaper than LPG. So if you just look at the fuel price, then I would say that gasoline is the winner here. But now if you look at the energy density, then the situation shifts a little bit. In this graph, the energy density is expressed as the amount of kilowatt hours per volume per gallon of fuel, and you can see here clearly, maybe not surprisingly, that diesel has the highest energy density per volume per gallon. So by means of energy density, diesel is the clear winner. So let's draw one more comparison. So we compared it based on the price you pay for the fuel. We compare it on the energy density of the fuel. Now for the last one, let's look at the fuel efficiency. So if you take this fuel and you burn it in an internal combustion engine, what is the amount of energy that you can recuperate out of the liquid fuel? And here we can see that diesel is winning again. So diesel has got the highest fuel efficiency compared to gasoline and LPG has got the lowest one. And then if you combine these 3 values together, so the price that you pay for the fuel, the energy density of the fuel, and the overall efficiency of burning this fuel in an internal combustion engine, then you get one value, which is the energy price expressed in dollars per kilowatt hour. And not surprisingly, you can see that diesel is the winner here, but it's pretty close to gasoline. And the reason for that is that at least in North America, the prices of gasoline are a bit lower than that of diesel. Now this was just a technical and financial comparison between the 3 different kind of fuels, but let's also mention a couple of externalities that you might want to consider when you're trying to choose which kind of fuel is best for your setup. Now the first one we could identify is the fire hazard, because there's a clear difference between the group of LPG and gasoline versus diesel. Diesel is just pretty hard to set on fire. So that's something to consider. But at the same time, the second one is the availability, because in many parts of the world, it might be easier to get one of the fuels over the other one. So certain countries is much easier to get gasoline, certain countries are actually easier to get diesel. So this is also something to consider. And the third one regarding fuel rotation is quite interesting. It really depends on your situation. So I don't know if you're in a cottage, in a house, a boat, or an RV, and whether or not you should be concerned about your fuel getting old, because I don't know how often you use your fuel. But a certain situation, for example, if your main engine runs on diesel or gasoline, you might also want to consider for the overall ease of operating all your systems to choose the same kind of fuel source for your generator as you're using for your main engine. And the last one I want to mention is regarding noise levels, because diesel engines, they work with self-combustion, so they don't have spark plugs that ignite the fuel, and therefore diesel engines, they are typically way more noisy compared to gasoline engines. So if this is an important factor for you, you might want to stick with gasoline generators. So these are just a few of the externalities that I want to mention regarding the different fuel options that you might want to consider. So you've got a bit of an idea what you can expect if you go for one fuel source over the other one. And this brings us to the conclusion of the chapter on generators. So thanks for sticking me all the way to the end, and I'm sure you learned quite a bit by now.